Hello friends, this is Durga again from Technology Mentor / ITversity. As part of MapReduce application development using Hadoop APIs, so far we have seen several things. We started with simple MapReduce applications using default behavior as well as the record count, and then we have spoken about a couple of full life cycle implementations to get average stock volume per month, where we have spoken about combiners, reducers, and all the fundamentals of MapReduce APIs. And then we went ahead and started implementing key values, custom key values. Um, then we have implemented top 3 stocks by volume, in which we have seen comparators, partitioners in detail. And after that we have seen compression, and now we will talk about another very important concept called counters. And first let us talk about what is counters. So counters are primarily to gather statistics of your MapReduce jobs. It can determine the data quality um, uh, if you try to figure out any issues as part of your MapReduce programs. Counters can give some basic information which we can use to troubleshoot the issue further. It is primarily implemented using Java feature called enums, and there are predetermined counters, and those predetermined counters can be seen using command line counters API by writing simple Java programs. And also, if you want to add custom counters to get more information about your MapReduce program, you can do that also. And as part of custom counters, there are user defined counters where you can actually define your own enum like any other counters we have. And also there is a concept of dynamic counters where you can actually um, generate the counters at runtime. So that being said, let us run a simple MapReduce program. Which we ran towards the end of the last uh, video on compression. So it will take a while, and then at the end of the run, you will see the counters information for this run. And we will review once it is successfully run. So the program is successfully ran, and you can see after the progress, once it is 100% done, when the job is completed, it have displayed the counters. And also we have seen this counters information can be retrieved using resource manager web interface also. Here also you can see the counters, and it gives the same information. And the counters are grouped into several categories. There are 6 of them, and most important are job counters and MapReduce framework. File system counters are primarily for I/O details, how much data it is being read and how much data is being written. And then job counters, which is very important group, contains how many map tasks are ran for this MapReduce application, how many reduced tasks, and how many of the map tasks are actually data local. And then several other important information like how much IO time, how much CPU time, all those information is given as part of job counters. And then the most important MapReduce framework, the most important counter group is MapReduce framework, and it actually tells you how many are the input records, how many are the output records for mapper, reducer, combiner. And this is very important information. If you think about it, in a large cluster where you are running hundreds and thousands of jobs, If you want to see how much data is being processed uh, by the jobs, and if you want to see the trend, or how the job counters are performing across the jobs, if there are any performance implications at a particular point in time, all that information you can actually collect and do some analytics on top of your counters to get a good idea about the performance of your cluster. So for that reason, reading these counters after execution of the jobs is also very important, and you can read this information in multiple ways. One is using command line. First, let us see the command line, how we can use it to get these details, and then we will write a we will write a simple Java program to get this counters information programmatically. So as we have mostly we have seen Hadoop fs command to interact with the HDFS, and Hadoop jar to submit the jobs. And then there is another command called yarn, which will give you the details about yarn applications. But when it comes to MapReduce jobs in Hadoop clusters, MapRed is the command which you should use more than any other command. And MapRed have several commands, in which job is the one which will give the details about the jobs. And you can see that there are few subcommands under job. The important ones are submit. If you have a job file and if you want to submit using job file, you can actually do that using minus submit. You can use minus status to get the status of your job, and counter is the one which will give the uh, details about your counters. And you can see that it takes 3 parameters. First one is job ID, second one is group name, and third one is counter name. And you should understand how this group name and counter name should be passed, and we will see that in few minutes. Minus kill is to kill the running job, and if you want to set the priority as part of the queues, you can use set priority. And then list is to list the jobs that are either running or that are already completed. If you just do mapped job list, it will show you the running commands. If you run it at this time, you will not see any results because there is nothing running on the cluster. All is the command. So if you pass mapped job minus list and then all, then it will list all the MapReduce jobs, whether they are failed, successful, or completed. Failed, completed, or killed. Since the last boot of our cluster will be listed by using minus list all. And list active trackers, blacklisted trackers, they are to tell if there are any node managers that are blacklisted. Also to list all the active node managers or task trackers. And then there are a few other things which are not that important at this time. We will focus on the counter. So the counter command, if you want to use, you have to start with mapped job minus counter, and now you have to pass the group name. And the group name is controlled by a few enums. So I'm going to browser and going to Hadoop API, and there are several so under org.apache.hadoop.mapreduce, there are several enums. One is task counter, other one is job counter. So job counter will contain all the enums that are part of this one, and task counter will contain all the enums that are part of MapReduce framework. You can click on these things and you can see the list of enums it supports. So list of metrics it supports, and job counter is all about num failed maps, num data local maps. So if you go to here, that data local maps will be translated to this one. And also there are other counters also which are not uh, displayed here. I think if there are any failed, they will be automatically displayed, but these are the default ones which are being displayed. And all of them will be represented using one or more enum constant. Data local maps is for data local map tasks, and there are several other things. And then task counter, if you see there are a bunch of enum constants, you can see that there is a map input records, which will map underscore input underscore records, which is map space input space records as part of the counters that are displayed. So we need to be familiar with the uh, mapping between group and the enum, and the mapping between metric to the, what is the syntax, metric to the counter name. So in this case, group name should be the enum which we want to get. So the enum is task counter, and let us see the metric related to reduce input groups. So reduce input groups are 522, and we should see the result 522 by trying to read this metric. Hit enter, and okay, I need to pass the job ID and the job ID. So the first parameter for my minus counter subcommand of mapped job is the job ID. So we need to get the job ID, and in our case job ID is 43, ends with 43. Hit enter. Now you can see 522 here. Now let us see how we can retrieve this information as part of the simple Java program. The Java program also looks like, means the Java program to get the details of counters also look like a map reduce application. So let me create a package here first. New package, counters, and then new class, counter testing. Hit enter. As it will be similar to map reduce application, we will have extends, configured, implements tool, and let me import this. And then we have to add a run method, and also we need to add a main function so that we can invoke this program. Okay, system dot exit tool runner dot run new counter testing args. Okay, and here we have to get the cluster object. So first let us create an object called job ID, and we will be passing the job ID as parameter. Okay, and then we will also pass the group name, and then we will pass metric name. What is that? Counter name. So counter name equal to arg0 of 2. Okay, and then we need to create an object called cluster. and the cluster has a constructor to get the configuration which can be built using configuration object, and we are getting the configuration object by using getConf function, and then we are actually building the job ID using cluster.getJob. So there is a deviation from the earlier MapReduce applications. You can also build the uh, job job object like this. In this case, we are trying to get the details of the job that is already submitted. So we have to do this way. We have to build the cluster object, and then we have to build the job object by passing the job ID dot for name. Means it will build the job ID object using which the job object will be built. And then we need to build an object called counters, and here let me first import this one. Job have a method called getCounters, and we have to use it to get the counters object and build the counters object. And once you have this, you can say system.out.println. So we are trying to print the counters information, and the counters have a method called findCounter, where it can take the group name and counter name. And here our group name is group name, so whatever we pass, and the counter name is whatever we pass here. And then we have to do dot get value. In all these in our case it is primarily long, so we have to use get value function. Now we are ready. We have created the main function, and in main function we are invoking this run method to get the details of the job that is already ran, and which is primarily the counters. And from the counter there is a method called findCounter, using which we can pass the group name and counter name and get the details of our job. So let me run as Maven install. And let me get out of this cluster because I need to do SCP. Hit enter. Now SSH. Hadoop. And now we have to run Hadoop jar nysc, and the program name is nysc.counters.countertesting, nysc.counters.countertesting, and it takes 3 parameters. The first parameter is the job ID, and in this case we can just pass the enum name. We don't need to pass the entire class. And then the counter name. Okay, and so I have to rebuild properties. I need to sort out this issue, how to fix it permanently, because sporadically it is changing. Okay, and now I have to do run as Maven clean, run as Eclipse, and then run as Maven install. And then I have to SCP, and then I have to do SSH. And then I have to run this program. I think I have to pass the complete path org dot apache dot mapreduce dot task counter and hit enter. Okay, it is org.apache.hadoop.mapreduce, and you can see the result 522. So when you actually so you can actually run the sorry you can actually develop MapReduce type of applications to get the counter information, but it is not actually MapReduce application. It just needs to invoke the tool object by using tool runner.run method to actually submit it as Hadoop jar command. So that's why we implemented that way. So using that method or using the command line approach, you can get the periodic information for all the jobs that are completed in your cluster, and you can dump it into a database, and you can trend you can keep track of what is going on your cluster based upon the counters. That being said, that's it as part of this video. We will see how to actually build the custom counters. I will try to define a problem statement and then work on building a custom counter, both the user defined as well as dynamic counters, and see how we can actually get the data quality information and diagnose certain problems as part of our MapReduce applications using the counters as part of the next video. I hope you are enjoying the content of the channel. If you like this video, please click on the like button. If you want to provide feedback or ask any technical question related to this topic, please leverage the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content than just big data or Hadoop. Thank you. Bye.